Hello friends, so here is another question on solving linear equations in two variables using elimination method. So the two equations are 1 by 2 into 2x plus 3y plus 12 by 7 into 3x minus 2y is equal to 1 by 2, and the second one is 7 by 2x plus 3y plus 4 by 3x minus 2y is equal to 2, with the condition 2x plus 3y is not equal to 0, 3x minus 2y is not equal to 0. Okay, so it's a very good question because there are multiple layers to it. We'll see how we'll solve it. So first step, we have to write the equations as they are, and assign numbers to them. Okay, so we have 1 by 2 into 2x plus 3y plus 12 by 7 into 3x minus 2y. Say this is equation 1. Sorry, I have not is equal to 1 by 2. This is equation 1, and then we have 7 by 2x plus 3y plus 4 by 3x minus 2y is equal to 2. This is equation 2. Now if you see, here we have 2x plus 3y, here we have 2x plus 3y, here we have 3x minus 2y, here also we have 3x minus 2y. So here we have to use the concept of substitution through addition of new variables. So let's say we make such a substitution as 1 by 2x plus 3y is equal to u. Okay, that's the first one, and 1 by 3x minus 2y is equal to v. These are the two new variables that we have introduced, u and v, and we have substituted them from 1 by 2x plus 3y and 1 by 3x minus 2y. Now when we substitute u and v in equation 1 and 2 in place of 1 by 2x plus 3y and 1 by 3x minus 2y, we have the equations as u by 2 plus 12 by 7v or 12v by 7. Okay, that is equal to 1 by 2. Let's call it equation 3, and we have 7u plus 4v is equal to 2. Okay, so now this is equation 4. So now here what we can do, in this equation 3, it is in fractional form, so we'll multiply the LCM of the denominators, that is 2 and 7 on both sides, to convert it into standard form. So 14 will multiply on both sides, here and here. So we have this 7 and this 2, 14, that is 7, 7, 14, 2. So we have equation 3 as 7u plus 24v. 7 cancel with 14, and here we have 2 multiplied with 12, that is 24. So 24v is equal to 7. Let's call it equation 5. So we have 7u plus 24v is equal to 7, and 7u plus 4v is equal to 7u plus 4v is equal to 2. That is equation 4. Now here, if we subtract these two equations, we'll easily cancel u. Now we have to go for elimination, variable elimination. So here we have 7u, 7u. Simply we can subtract these two equations and we will cancel u. So we'll do that. Minus, minus, minus. So we have these two cancelled. Here 24 minus 4, that is equal to 20v, and 7 minus 2, that is equal to 5. So 20v is equal to 5. So here what I have done, see this. Let me write it here. I have done equation 5 minus equation 4. Simply this operation I have done here, and we have got this result. Now v is equal to 5 by 20, which is equal to 1 by 4. So we have got v is equal to 1 by 4. Now if I substitute this here, okay, in this we have 7u plus 4v, v is 1 by 4, is equal to 2. Cancel, that implies 7u is equal to 2 minus 1, which is equal to 1. That implies u is equal to 1 by 7. Okay, we have got u is equal to 1 by 7, v is equal to 1 by 4, but it's not over here. Now we have substituted u and v for 1 by 2x plus 3y and 1 by 3x minus 2y respectively. So what we have here is this. So we have u is equal to 1 by 2x plus 3y, that is equal to 1 by 7, and v is equal to 1 by 3x minus 2y, that is equal to 1 by 4. Okay, so here from this we have 2x plus 3y, that is equal to 7, and 3x minus 2y, that is equal to 4. So let's assign them new numbers. So we were last at equation 5. So equation 6 and 7. So let's call this equation 6. Let's call this equation 7. So here if I write them, let's write them side by side, okay. 2x plus 3y is equal to 7, and here 3x minus 2y is equal to 4. Okay, in this way it will be better. So here we have plus, here we have minus. So it's simple and straightforward to cancel y here. Okay, so what we'll do, we'll match the coefficients. Here I will multiply 2 on both sides, and here I will multiply 3 on both sides. So we'll have 4x plus 6y is equal to 14, and 9x plus 6y, sorry, 9x minus 6y, sorry, 6y is equal to 12. So we'll simply add them. So, it will be minus, okay. and here it will be plus. Okay, so we have 13x, this gets cancelled, plus 6y minus 6y, and 13x is equal to 26. Okay, 13x is equal to 26. That implies x is equal to 26 by 13, that is equal to 2. So we have x is equal to 2. Okay, so x is equal to 2, we can use any of these equations to get the value of y. So that implies here, if I substitute x is equal to 2, that implies 2 into 2 plus 3y is equal to 7. That implies 3y is equal to 7 minus 4, which is equal to 3. That implies y is equal to 3 by 3, which is equal to 1. So we have y is equal to 1. Okay, so we have got x is equal to 2 and y is equal to 1. The solution of the given linear equation in two variable. So why this question is good is, first we had the two initial linear equations in this form, so we introduced two additional variables, substituted them for the these 1 by 2x plus 3y, 1 by 3x minus 2y. Then we used elimination method to get the values of u and v. Then also the two new equations came in the form of this, because the substitutions that we made, we were for 1 by 2x plus 3y, 1 by 3x minus 2y. So we got two more linear equations in two variables in terms of x and y here. But they were in simple direct format, straightforward format. So again we used variable elimination method to get the value of x and y. Okay, so as I said, it had multiple layers to it. So we solved each part and we finally arrived at the result. Okay, so we have x is equal to 2 and y is equal to 1.